Okay, so today we're going to be talking about lines. A line is the relation of points with a constant change. And that constant change is our slope. The slope of a line, when it's not given to us, can be calculated. We use m to denote slope, and it is y2 minus y1 over x2 minus x1 for our 2 points. x1, y1, x2, y2. Okay, so when I calculate the slope, I take y from the second point minus y from the first point over x from the second point minus x from the first point. Slope that runs parallel to the y-axis is undefined. So now let's go ahead and take a look at our different types of slope that we can have. There are 4 different kinds. Let me draw the grids. This first one is a positive slope because as I go from left to right, my line goes up, or it's growing, which means my slope is positive because my rate of change is positive. If we decrease from left to right, that is a negative slope. Because as I keep going in my x values, it's getting smaller and smaller. We can also have a 0 slope, which is a horizontal line. So this is a line that runs parallel to the x-axis. If you can walk on it, it's 0. If you can't walk on it, it's undefined. So this is what I mean by a line that runs parallel to the y-axis. It is a vertical line that goes straight up and down. I cannot walk on this one. I can walk on this one, I can walk on that one, and I can walk on this one. So if it's a line you could not possibly walk on, then it is an undefined slope. Formally, we can also describe slope as our change in y, so delta y, over change in x, delta x. And that is written out as change in y over change in x. So the first thing we're going to do is we are going to find the slope between 2 points, and we're going to graph the line. So these are examples. So we're going to find the slope, and then graph. Our 2 points are point A, which is negative 1, 4, and point B, which is 3, 2. So the first thing I'm going to do is I'm going to calculate my slope. So slope is equal to y2 minus y1, so 2 minus 4, over x2 minus x1, 3 minus a negative 1. A double negative becomes positive, so that becomes a 4. 2 minus 4 is negative 2, over 4 is negative 1/2. Slope is rise over run, in case you don't remember that either. Which means I can either go up 1 to the left 2, or I can go down 1 to the right 2, depending on where you want to put the negative that's out front. It can go with either value because it's going to create the same line either way. So let's go ahead and graph this and prove that. So I'm first going to put point A on here. So A is x is negative 1, y is positive 4. So I went left 1, up 4. Point B is 3, 2. So I'm going to go right 3, up 2. And then I can go ahead and draw my line. And I'm done. You can see that every single point on this line matches up with our slope. So from A, if I went down 1 to the right 2, hey look, I ended up on my line. If I went down 1 to the right 2 again, I end up at point B, which is again on our line. So every single point will be a slope of -1/2 from the points around it. Okay? Let's go ahead and do another one, because this is wonderful practice for us. So this time, I'm going to do the same thing, but my points are A, 2, 5, and B, -2, -1. First thing I want to do is calculate my slope. So I'm going to have -1 minus 5 over -2 minus 2. -1 plus a -5 is -6 because they're both negative. -2 plus -2 is -4. The negatives can cancel each other out, and I can reduce this to 3 over 2. So my slope has a rise of 3 and a run of 2. When I go ahead and graph this, point A was 2, 5. And then point B was -2, -1. Okay, B. I go ahead and draw the line that connects them. Oop, that did not work that well. I'm a math teacher, not an art teacher, so I don't care if your line is perfect. However, it should be close. Okay, just as I expected, this is a line that grows from left to right, and it had a positive slope. So that matches up perfectly. Let's go ahead and do another one. So this is point A, which is 4, 3, and point B, which is -2, 3. I want to go ahead and do my slope. So slope equals 3 minus 3 over -2 minus 4. 3 minus 3 is 0 over -6, which is just 0. So I know that when I graph this, my line is going to be a horizontal line. So I go ahead and I graph my points. I have +4, +3, and I have -2, +3, A and B, and I draw the line that goes through both points. And sure enough, it's a horizontal line, just as I predicted. One last graphing example with 2 points. This one has the point A, which is 4, -1, and B, which is 4, 4. As I'm looking at this, what do I notice about my 2 points? They have the same x value, which I know means that when I graph it, I'm going to have 2 points at x equals 4, which means it's going to be a vertical line, which will have an undefined slope. Let's prove it. I go ahead and I plot point A, which is 4, -1. And then I plot point B, which is 4, 4. And I draw my line that connects them, and sure enough, it's a vertical line. It's a little crooked because I'm not perfect, but it is what it is. Let's calculate the slope too, just to make sure that would match up. I get 4 minus a -1, which turns into 4 plus 1, over 4 minus 4. Which reduces to 5 over 0, which is undefined. So I think it's safe to say if my 2 points contain the same x value, it will be an undefined slope that gives us a straight line, a vertical straight line, sorry. What about in this example? What did I notice about my 2 points? Well, they had the same y value, which means, since it gave me a horizontal line, that any 2 points that contain the same y value are going to be a horizontal line, which is a slope of 0. Okay, so just some nice little pieces of information. So now we're going to graph another line, but we're going to do it with different given information. So, given point P, which is 2, 1, and slope 5/3, it wants us to graph the line. Okay, so the first thing I need to do is I need to plot 2, 1. The first thing I'm going to do, I'm going to go to 2, 1 and plot my point. From there, I'm going to find my next point using my slope. Remember, slope is rise over run. So, since 5 is positive and 3 is positive, that indicates I have a positive rise and a positive run. So I'm going to go up and right. It is also possible that a double negative will also give us a positive, right? Because a negative divided by a negative is also positive. So I could go down 5 and to the left 3. Okay, so if we have a positive slope, we can do a double positive up to the right or a double negative down to the left. It doesn't matter which one you do, it's still going to make the same line. So from here, I'm going to do a positive slope first. So I'm going to go up 5 and then to the right 3. And put my dot. Then I'm going to go ahead and I'm going to go down 5, so I'm going to do a double negative slope, and to the left 3. Sure enough, they line up perfectly, so I can draw my line. Oh, close enough. And that's what I get, approximately. I expect you to have at least 3 points on your line before you graph it. Okay, so now let's do another one, just for good practice. This time I'm going to use point 2, 1, just like we did before, but my slope is going to be -5/3, or -5/3. Okay, just like we did before, I'm going to plot 2, 1. To 1, put my point. This is a negative slope, which means I can either put the negative with the 5 or with the 3. Okay, so if I put it with the 5, I have -5/3, which indicates that I'm going to go down 5 to the right 3. I could also instead put the negative with the 3, which is 5/-3, which indicates I'm going to go up 5 and then to the left 3. Either direction you go, you're going to get the same line, so it does not matter. So I'm going to do the -5/3 first. So I'm going to go down 5, and I'm going to go to the right 3. Then I'm going to do the 5/-3 just to see what happens. So I'm going to go up 5, and I'm going to go to the left 3. Okay, look at that. They're still going to make the same line, so it does not matter which direction you choose to go, as long as you're keeping it consistent. So this was a negative slope, which means we could only go one negative direction. Okay, if it's a positive slope, we can go 2 positive, or we can go 2 negative. It does not matter. So let's clarify some things. And I'm probably going to run out of time on this video, which means the rest will be on the next video.